Good afternoon, sir. This is Janvi from CSCA section, and my topic for CAA assignment 2 is binary search tree with search operation and example. So this is the topic that I got for CAA assignment 2, that is binary search tree operation with example and detailed step-by-step process I'm going to explain. So first of all, the outline of my topic is introduction, binary search overview, search operation with example, time complexity, advantages, applications and implementations, and finally conclusion. So these overall things I'm going to cover in this PPT. So first, introduction. So in this binary search tree presentation, I'm going to explain the step-by-step procedure and with an example. So here in this picture I have given a small minute details about the binary search tree, the definition and the properties, operations that can be performed using binary search tree. We will get to know more about this in the next slides. First, let us get an overview of what is binary search tree. So basically a binary search tree is a data structure that allows for efficient searching, insertion and deletion operation. It consists of nodes where each node has value and two child nodes left and right. So I know it is a little bit complicated. So first let me tell you. So this is the root node, and this B is the left child of the root node, and this C is the right child of the root node. So this whole thing is the left subtree of the root node A, and this whole thing is the right subtree of the root node A. So the definition is that binary search tree is a binary tree in which every node contains a smaller value in left subtree and larger value in right subtree. So this B value will be definitely lesser than the root node A, and the C value will be greater than the root node A. So this is the definition of the binary search tree. Now search operation. So the binary search tree has different operations like insertion, search and deletion. So for now we will get to know about the search operation. So the search operation in binary search tree involves comparing the search or target value with the value of the current node. If the search value is less than node value, then it moves to the left subtree, and if the search value is greater than the root value, then it moves to the right subtree. So this is how a search operation is performed. Now let's look at the step-by-step procedure of what really happens in a binary search tree search operation. So in step 1, we first read the search element from the user, and then after reading this element, we will compare the search element with the root node. If the root node and search element is same, then we will return the root node is found. I mean the given node is found, and we will not continue the process of searching. But when the root node and the search node are not same, then we will check whether the given search element is smaller or greater than the root node. If it is smaller, then we will go to the left node, which means left subtree, and then we will compare the search element with the left subtree element. If these both are similar, then we will return the given node is found. But still, if those are not similar, then we will again look for if the search node is greater or smaller than the root node, and we will repeat the process until we will find the search element or given required node. If after completing all the comparisons and we will still not found the search element, then we will just say that the element is not found and terminate the process. So this is all the thing that have that I have in this slide that I just simply told. We will further know about this with an example. That is, so let us take the following numbers as binary search trees. Here I have given 8, 3, 10, 1, 6, 14, 4, 7, 13. So these are my elements in a binary search tree. So let us take a search element for performing the search operation, that is 6. So here I have shown in the figure that we can represent the thing that 8 binary search tree. In binary search tree, these elements can be represented like this, like here, like this in this figure. First, in every question or anything, we will write the first element, this first element in the first root node, and then we will compare this 3. So 3 is lesser than 8, so we will write 3 in the left subtree, and 10 is larger than 8, so we will write that in the right subtree. Similarly, we will arrange all these elements as a binary search tree following the rules. Now, so the starting with the root node 8, we will compare the value 6. 6 is not equals to 8, so we will then compare if 6 is greater than 8 or smaller than 8. So we all know that the 6 is lesser than 8, so we will move to the left node, that is 3. So here you can see that the left root node is 3, so we will compare this 6 with 3. 6 is not equal to 3, so then we will check whether the 6 is greater than 3 or smaller than 3. So when we look, that we all know that 6 is greater than 3. So greater a value which is greater than root means it must lie in the right subtree. So here we again compare if the 6 is similar to the such element. Yes, 6 is similar to the such element, which is 6 equals to 6. So simply we just say that we have successfully found the target value in binary search tree, and the search operation is completed as we have found the target value. So here I have just taken a small example of binary search tree. Now let us look some other aspects in binary search tree, that is time complexity. So the time complexity of binary search tree is big O of log n, where n is the number of nodes. So this here I have given in the little information about the time complexity, like about best case, average case, and worst case. So we have big O of log n as a time complexity. Next, advantages of binary search tree. So advantages is that binary search tree offers efficient retrieval due to its balanced structure and logarithmic time complexity. So it has the least time complexity, which is good. So it provides reliable and scalable solution for searching large data sets. So binary search tree simply makes the process of searching an element or an information easy. So this is the advantage of binary search tree. And the application. So binary search tree has a wide range of applications, like in database systems, file systems, network routing algorithms. They're also implemented in programming languages and libraries. So a common life example is that when we go to bank, we can access data easily using these binary search trees. So here it is a picture. In this picture, we have the overall view of binary search tree, like what is a binary tree, and about the operations on binary tree, all these things. Next, we have conclusion. So in conclusion, the binary search tree has 3 operations: search, insertion, and deletion. Search operation offers an efficient and scalable solution for a large task. its balanced structure and time complexity makes it valuable data structure for various applications. Thank you for listening.